find the sample size for a particular confidence interval or whatever, you're going to have to use a specific formula from the notes, the PowerPoint notes. This formula, I believe, is from page 20 something. 26. No, there it is, 29. There's the formula for, we're talking about a population mean. There's our formula. Okay. So it says you want to obtain a sample estimate for a population mean. Based on previous evidence, you believe the population standard deviation to be approximately 41.4. You would like to be 90% confident that your estimate is within zero point 0.2 of the true population mean. This is going to be our E. So we need to figure out what Z value is cutting off the middle 90%. So if we look at our Z or normal curve, standard normal curve, whoops, don't mind the sloppy handwriting. This is 0. Looking for the Z values that cut off the middle 90%. I'm looking for this Z value or the negative. Doesn't matter. We'll just go with the positive. Okay. So in my calculator, I'm gonna find that first. I'm gonna go to distributions, inverse normal because I have the percentage. So what area is to the left of this Z value? That's all this stuff. So that's not just going to be 90 because there's 5% here and 5% here, making up the total 100%. So the area to the left of my Z value is going to be 95% or 0.95. Mu is 0, sigma is 1. Paste. So once I cut this off, but it says use your Z score to 3 decimal places. So this Z score is 1.645. That's my Z. So now I'm going to take that, I'm going to multiply it by sigma, 1.645 times 41.4 divided by zero point 0.2, my margin of error. And then this thing has to be squared. So we get 115950 point yada yada yada. So in order to make sure our sample size is truly large enough, no matter what this variable this decimal is, we're always going to round this up. So this is going to be 115951 because rounding up ensures that our sample size is in fact large enough. Okay. Same thing here for these, except we're going to use a different formula because we're talking about a population proportion or percentage. So we're still finding the same Z value that cuts off the middle 90%. Okay, that's what we did here. So we can use the same Z value. Z is going to be 1.645. We want a 1% margin of error, so E is going to be 1. Or we'll put that as, sorry, zero point 0.01. My mistake, zero point 0.01. Right as a decimal. And then since we don't know P and Q, we always assume P and Q are going to be 50%, unless they give it to us, which they did not. So now I'm going to take my Z value, 1.645, raised it to the power of 2, times P times Q, times zero point 0.5 times zero point 0.5. And then I'm going to do 0.01 squared on the bottom and divide that by E squared. This divided by this. So it looks like it's 6,765.06 or 6,766. Okay. Same thing for 17. The only difference here is that we know P. So we're going to let P be 0.61 and Q will be 0.39. 98% confidence. So when we do that in our calculator, we're going to go to distributions, inverse normal, and we're going to use 0.99 because it's 98%, which means there's 1% on either side. So it's 99% to the left of our Z value. So we get that. We'll round it to 3 places. So we'll get 2.32 2.326 times 0.61. We'll have to square that first, sorry. Squared times 0.61 times 0.39. And we will divide by 0.025 squared. That divided by that. 2059.3 or 2060. There you go.